Welcome to HackerFrogs After School. This is the first workshop for Intro Linux OS Operations. Let us begin. For this workshop, we'll be using Windows 11 as our host machine, but the methods we'll use are nearly identical to how it would be performed using Windows 10. Since most computer users use Windows as their operating system, we'll be using the built-in Windows tools to connect to another computer, the Bandit CTF server, which is using Linux. Through the Bandit server, we'll be learning how to use Linux OS commands. The first thing we want to do is open up a Windows command prompt window, since we'll be connecting to the Bandit CTF server using that tool. To access the Windows command prompt, we'll go down to the search field at the bottom of the Windows toolbar, then type in cmd. The command prompt app should show up as the best match. Click on that, and the command prompt window will appear. The Windows command prompt is a command line interface, which means all commands executed in the command prompt must be typed in. In order to connect to the Bandit CTF server that we'll use to learn Linux, we'll use the SSH program to remotely log in and access it. In the command prompt window, type in the following command: ssh bandit@bandit.labs.overthewire.org -p2220. Before we confirm the command, let's break down what the command will do. SSH is the name of the program we're running. It allows secure access to other computers that are using the SSH service. Next is the user account name we want to use to log in. In this case, the user is Bandit0. The @ symbol is used to indicate that this is a username, and that the portion that follows is the name of the server: bandit.labs.overthewire.org. The final part of the command is -p2220, which indicates which networking port to connect to. Press the Enter key to confirm the command. Then, when asked whether we are sure we want to continue connecting, type in Yes, then hit the Enter key. Then we'll be prompted to enter the Bandit0 user's password. We will type in the password, which is Bandit0, the same as the username. Note that we will not see feedback from the command line. This is normal behavior with Linux, and we will not see the password as it is being typed. Once logged in, we will be remotely connected to the Bandit CTF server as the Bandit0 user, and start part 0 of the workshop. Let's look at the level's objectives at the Bandit CTF website. Using a web browser, we navigate to the following URL: https://overthewire.org/wargames/bandit1.html. As we can see in the level goals section, the password for the next level, Bandit1, is in the file named readme in the home directory. When we log into a Linux system, we begin in our user account's home directory by default. To read the contents of our current directory, type in ls, then press the Enter key. As we can see, the README file that was mentioned in the level goals is located in this directory. We can read the file with the cat command. Type in cat, then space, then the name of the file. The output of the command is the password for the next level's user account. Please keep in mind that the passwords for the Bandit levels are changed every few months, so the passwords in this video may not be valid anymore. Using the mouse, highlight the password, which can also be referred to as a flag. Then use the keyboard shortcut Ctrl-Shift-C to copy the password. We're finished with this level, so enter the exit command to log out of the server. On our Windows machine, we can copy the password to a text file with the following command: echo space B1 space. Then we use the keyboard shortcut Ctrl-Shift-V to paste the password we copied. Then space, double greater than symbols, then the name of our file. Let's call it banditpass.txt. The echo command tells the computer that whatever follows will be output to the terminal. But combining it with the double greater than symbols tells the terminal to redirect and append the output to somewhere else, in this case, to a file. So we now have a file on our Windows machine with the Bandit CTF level password. We'll be adding to this file as we complete Bandit CTF levels. We can access the file on Windows with the type command, as in type space banditpass.txt. Remember, reading files from the terminal on Windows is the type command, and on Linux, it's the cat command. That's the end of Bandit level 0. Bandit level usernames follow the pattern of Bandit, then the level number, such as Bandit 0. So we know that to access Bandit level 1, we log into the Bandit CTF server using SSH as the Bandit 1 user. We can repeat previous commands in the terminal by using the keyboard up and down arrow keys. This is an easy way to repeat long commands. So we'll access the SSH command we used to access level 0, but slightly edit the username to access Bandit level 1. We can move the cursor back and forth in the CLI with the left and right arrow keys. For the password, we can use the Ctrl-Shift-C method we used to copy the password for level 1. Then Ctrl-Shift-V to paste it into the terminal, then log in. Let's go back to our web browser and click on the level 1 to level 2 link. The level goal indicates that the password is located in the file named dash or minus, located in the home directory. When we go back to the terminal window and use the ls command, we see that there's a file named dash in our current directory. But if we use the method we used in the previous level, the terminal becomes unresponsive. But we can cancel out of an unresponsive terminal by using the Ctrl-C keyboard shortcut, which cancels the currently running command. It's generally considered bad form to include special characters at the start of file names, but we can access the file by explicitly including the directory name in the ls command. cat space dot slash dash. In Linux, dot slash references the current directory, so Linux knows that the minus sign refers to contents in the current directory, instead of interpreting the minus sign as a special character. We can copy the password like we did in the last level, highlighting the password and using the Ctrl-Shift-C shortcut. We exit from the server, then use the echo command to add this password to the banditpass.txt file, labeling the entry B2 instead of B1, and inserting the password we copied just now with the Ctrl-Shift-V keyboard shortcut. That's the end of Bandit level 1. As usual, we use the SSH program to log into the server using the Bandit 2 username, and we paste the password in to log into the server. Let's take a look at the level goals on the web page. The goals state that the file we want to access is called spaces in this file name, located in the home directory. We go back to the terminal window and use the ls command to list out the home directory's contents. The file we're looking for is here. We try to read the file using cat in the usual way, but it doesn't work because there are spaces in the file name. It's generally considered bad form to include spaces in file names in Linux, but we can work around the problem in a couple of different ways. The first way is to use the usual cat command, but wrap the file name in quotes. The second way is to include a backspace character before each space, which forces Linux to interpret the spaces as part of the file name instead of a separate portion of the command. Either way, we now have access to the password for the next level of the game. So we copy the password and exit the server. Then we copy the password to our Bandit pass file. That's the end of Bandit Level 2. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. We log into the next level in the usual way, adjusting the username in the SSH command, and pasting the password to log in. We then look at the level goals on the web page. The level goal states that the target file is hidden and located in a directory named in here. We can output our present working directory by using the pwd command. Remember, by default, when a user logs in, their starting directory will be their home directory. If we use ls to list out the directory contents, we see that there's something called in here in this directory. We can run a modified ls command with the -l flag to receive more detailed output. The D at the beginning of the output indicates that in here is a directory. We can navigate to the in here directory with the cd command, as in cd space in here. The cd command allows us to change our current directory in the file system. If we use the pwd command to check our current directory, we see that it's changed. Now let's find the file with the password written in it. If we simply use the ls command, nothing is returned because the level goal stated that the file is hidden. Hidden files and directories in Linux are created by prepending a dot or period to the beginning of the file name. We can issue an ls command that reveals hidden files by supplying the -a switch, which will return all files and directories, including hidden ones. From the output, we see that there is a file named .hidden in this directory, but what are the dot and double dot entries? In Linux, each directory contains two hidden directories. The dot directory refers to the current directory itself And the double dot directory refers to the directory immediately above the current directory in the file system. We can read hidden files in the usual way with the cat command. Cat space dot hidden. Now let's copy the password, exit, and add the password to our Bandit Pass text file. That's the end of Bandit Level 3. We log into Bandit 4 in the usual manner. Then we look to the web page for our level goals. The level goals say that the password is stored in a human-readable file in the in here directory. The implication here is that there will be files involved in the level that are not human-readable. When we use the ls command to list out the contents of the directory, we see that the in here directory is present. We use the cd command to enter the in here directory. Then confirm our location using the pwd command. Then we list out the directory contents using ls. There are 10 entries in this directory. If we attempt to read the file, we see that it doesn't contain anything legible. From the level goals, we know that this level deals with human-readable files and non-human readable files. So let's use a new command to identify which is which. File /file 00. The file command is used to identify the contents of files, whether they belong to a specific file format, if they contain text, if they contain data, etc., etc. The -file00 file contains data, which means that its contents are not meant to be read by people, but rather by a computer program. The dichotomy here is that text is meant to be read by humans, and data is meant to be read by computers. So let's use a new command to identify which is which. File ***. That command should have worked, except for the fact that the files in this directory all start with special characters. We usually don't need to use the // to use the asterisk wildcard character, but because the directory contains files that start with special characters, it is required. The star, or asterisk, wildcard character is used in Linux to match every file or directory in the current directory. So our last command was applied to each of the files in the directory without having to type them all out. We can see from the output that -file07 contains text, so we can use the cat command to read it. Remember, we have to reference the current directory to read files with special characters. To finish up the level, we copy the password, exit the server, and copy the password to our Bandit Pass file. That's the end of Bandit Level 4. We log into the Bandit CTF server in the usual manner. Then we look at the web page for the level goals. The level goals state that the password is stored in a file under the in here directory and is human readable, 1033 bytes in size, and non-executable. Going back to the terminal, if we enter the in here directory and list out its contents, we see that there's 20 directories in here. And each directory has several files within it. We can use the Linux find command to search through all of these directories and find the file that matches the specific details stated in the level goal. Before running this command, let's review what the different parts of the command will do. Find is the name of the command. The next part, the // indicates which directory to apply the search to, which in this case is the current directory and all directories within it. The -type argument lets us specify whether to search for files or directories, in this case, files. The -size argument lets us specify the size of the file we're looking for, with the C appended at the end to indicate bytes. The exclamation point, also called a bang, is used to indicate exclusion. And the -executable flag indicates what is to be excluded, as in not executable files. Now let's run the command. We receive one match for all of the criteria we searched for, so let's read it with the cat command. We can copy the file path, then paste it in so we don't need to type it out. In this case, we can supply a file path with the cat command so we don't need to be in the directory to read a file there. And, as usual, we copy the password, exit the server, and copy the password to our Bandit Pass file for future use. Let's use the type command to read the Bandit Pass text file and look at all the passwords we've collected today. Let's take a few minutes to review the different Linux commands we covered in this workshop. The ls command lists the files and directories in the current directory. It can be used with the -l argument to output in a list format, and with the -a argument to include hidden files and directories in the output. These two arguments can be combined to produce both outputs. The cat command lists the contents of a file. The name of the file to be read must be supplied as an argument to the command. The echo command creates output based on whatever argument is supplied to it. It is very useful for creating output for redirection. Output redirection is the process of redirecting the output of a command, either into a file or into another command. Here, the double greater than symbols redirect output into a file, but if that file already exists, it will instead append to that file. The cd command changes the current directory to the one specified. The new directory must be supplied as an argument to the command. The file command identifies the type of contents for a specified file. The file name must be supplied as an argument to the file command. The find command allows a search of files and/or directories in the file system and matches files in the output according to the criteria provided by the command arguments. The argument -type searches by files or directories, and the argument -size searches for files of a particular size. The pwd command will output the name of the current directory. also known as the present working directory. In the next HackerFrogs AfterSchool Linux OS workshop, we'll continue learning Linux commands with the Bandit CTF. Looking for more study material on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs!